All right, this video should be pretty quick, pretty straightforward. This is just a quick little recap of things that we've talked about thus far. All right, so we're about 1/3 of the way through the unit. We've talked about special right triangles. We've talked about basic right triangle trigs, sine, cosine, tangent. Then we got into angles and periodic functions. Now, here we have some answer key work for previous worksheets. If you want to take a picture of the screen, pause, screenshot, do what you got to do. Same thing over here. One thing to notice on number 20, draw yourself a picture, okay? So this was, in the previous video, we kind of talked through that problem, but always draw yourself a picture with those problems. All right, little recap on special right triangles. We have a 45, 45, 90 triangle. So with those, the two side lengths are the same, and then the hypotenuse is whatever that leg length is times the square root of 2. For a 30, 60, 90 triangle, you have angle and side pairs. So the side across from the 30 is the short leg, called S. The side across from the 60 is the long leg, and that would be whatever the short leg is times the square root of 3. And then the hypotenuse, which is always across from the 90, is twice as long as this short leg here. So if you find the short leg of a 30, 60, 90, you can find the other two legs relatively quickly and easily. And then we get into right triangle trig. So sine, cosine, tangent of a reference angle theta. Remember, theta will never be our right angle. It will always be one of the two acute angles here for our right triangle. There's the phrase that we can use SOHCAHTOA. So SOH, sine opposite over hypotenuse. CAH, cosine adjacent hypotenuse. TOA, tangent opposite adjacent. All right, so let's do some practice problems because it's been a while since we've seen these over our special right triangles. So we've got 4 that we'll talk about, and we'll move on. All right, I'm going to go ahead and plagiarize a little bit so that way I'm not constantly reinventing the wheel here. All right, so for the first one, I want to figure out what are these missing side lengths. Well, it's a 45, 45, 90, so the two legs are going to be the same. So this other leg is also going to be a 2 rad 3. Then to figure out that hypotenuse, I'm going to take the leg measure and tack on a rad 2. So I'm going to have 2 rad 3 times rad 2. Well, since these numbers are both underneath a radical, they can multiply together. That's going to give me 2 rad 6. Let's take a look now at the 30, 60, 90. Let's see, they give me the hypotenuse. So they give me the 2s. Well, that means the short leg across the 90 would be plain old s. If 20 is the 2s side, then s would be 10. Which means y is going to be 10 times rad 3. Ooh, that's a terrible 3. There we go. 2 more. All right, here we've got a 30, 60, 90, or sorry, 45, 45, 90, but it's kind of been kicked on its side. The only thing I know right now is that these two legs are going to be congruent. Unfortunately, I have no idea what those are, but I do have 12. 12 is the hypotenuse, which is the s rad 2 side. So whatever that leg length is, times rad 2. So let's solve for that. That s rad 2 side is equal to 12. So if I wanted to solve, I'd divide rad 2 to the other side. So s equals 12 over rad 2. And right now I'm not too thrilled about having this radical in the bottom. So we're going to rationalize our denominator, meaning multiply top and bottom by that radical. If I'm multiplying top and bottom by the same thing, I'm technically just multiplying by 1. I'm just kind of being clever on how I write that 1. So this becomes s equals 12 rad 2 over a plain old 2. And 12 over 2 is 6, so 6 rad 2. So x and y are both the exact same value here, 6 rad 2 for each. All right, onward to the last problem for the day. They give me the side across from the 60-degree angle for a 30, 60, 90 triangle. So I know the side across from the 60. So the side across from the 60 is S rad 3. S is the length of that short leg, and then the hypotenuse is the length of that short leg times 2. So if I know X, I can figure out Y very quickly, and vice versa. So they give me the side across from the 60. I can set up the equation now. S rad 3 equals 24. And it's going to follow the exact same pattern that we just did. We're going to divide both sides by rad 3. We're going to rationalize the denominator. Act surprised when it happens. So we've got S equals 24 over rad 3. Yes, there are shortcuts to do this, which I'm sure some of you are kind of picking up along the way. I'm not going to walk through it because I don't want to risk confusing people. So now we have 24 rad 3 all over 3, 8 rad 3. So my short side, short leg, is 8 rad 3. The long leg is twice as big, 16 rad 3. All right, folks, that is it for this lesson. You know the drill. If at any point something didn't make sense, please let me know. And as always, good luck, have fun, be safe, roll tide.